intro that might not really be helpful. Good morning, everybody. Okay, so 7.3, we're about to go here. Start off class. Kiddos, we're looking at the example from last time, saying, doesn't make sense. But then we came back and said, wait a minute, where are we? We are in the system of equations chapter. I said, hey, where have we been? And I said substitution, because we started there. Then I said elimination, because that's where we went next. And then I asked basic ideas, but did the homework get hard? And what was all of your answers?
Yes.
Why?
Because website's way of doing it is different.
Okay, valid. Anybody agree with that?
Yeah.
Web design fill in the blanks can sometimes stink. But was that the only thing that was hard?
They like switch
Why did I
now.
focus? Was that the only thing that was hard? Focus. Was that the only thing that was hard?
No.
Okay, what else was hard?
Number 10, 11, and 12. Yes.
Okay, I need details besides 10, 11, and 12. Sasha, what else was hard?
The depending equations, we have to do like z equals a.
Oh. What was happening in the places where you had to let z equal a?
The equations, they're like multiples of each other.
Yeah, so that when you tried to solve, that's a good way of putting it. They were multiples of each other. They were technically what we could call equivalent. No, not equivalent. Consistent but infinite. That doesn't really help. That was the mistake I made the other day. But the equations end up being multiples of each other. So when you add or subtract or eliminate, what ended up happening?
It was like the same numbers.
Yes, and all variables are gone. Now, wait a minute. You don't hate all the time all the variables are gone. When are the times that you love when all the variables are gone? No, those are the hard
I
ones.
don't know what you're talking about.
Elimination.
Oh, 0 equals a number.
Why is it great if 0 equals a number? The x's are gone, the y's are gone, and it's a false statement. You're able to say what? They get to stop, right? What if all the variables aren't gone and you get something like x equals 2? You're not done, but what's the only thing you have to do to finish? Back substitute and go find the y, as an example, right? But Sasha's bringing up the third case, which is like, what if you get 0 equals 0, or 5 equals 5, or 7 equals 7? Then what?
Then you have to have 3.
You have to use let z equal a.
Yeah.
Now, I don't know, did that show up in 7.2, 7.1 a lot?
No.
I think it's showing up for the first time in 7.3. But yeah, that is going to be hard. So let's think for just a second about 7.1 and 7.2. 7.1 and 7.2.
Yeah, it'll
You
did? You guys like the water?
Not with the decimal though, right? With the whole number? Yeah. Okay, sorry, coming back. Coming back. But where did 7.1, 7.2 get hard? Or did it get hard? Maybe word problems. The headwind, maybe, right? A little bit. Anything else, Ryan?
I was gonna say like the airspeed.
Yeah. I got that. But everything else wasn't too bad. The numbers didn't get too messy, right? But when we get to 7.3, why is it just naturally going to get messier? You have 3 variables, and you have how many equations?
3.
So you're going to be doing a lot of numbers. Does that make sense?
Yeah.
But are the basic ideas really that much harder? Can we go to this example from yesterday? Someone walk me through what's the very first step that you're trying to do? Eliminate the x terms from what? 1 and 2 and 2 and 3. I'm trying to get rid of all the x's. But to do that, I have to work in pairs. Elimination or substitution needs 2 at a time. I only have 3 equations. So I'm going to work with the first 2 and the second 2. What did I model for you over here?
R1 minus R2.
R.
Oh, wait.
No?
Hold on.
That's negative.
I mean R2 minus R3.
R2 times negative 2
I think actually it was a positive 2R2. Double check me. Wasn't it
Yeah,
positive
yeah,
2R2?
Oh yeah, positive 2R2.
It's already a negative x.
Do you see how I'm using R's to talk about whole lines, to talk about whole equations? Why? Because I'm trying to show you this is what you're doing, and then you can double check. Someone was in here yesterday doing some of this homework, and man, it wasn't even someone here, it was from a different class period. But they kept on making mistakes. Do you know why they kept making mistakes?
Mislabeled.
It wasn't organized.
They weren't showing the work. Because they're like, oh, it's substitution elimination, I got this, and they were trying to do it all in their head. This is a lot to hold in your head. Now, some of you don't like getting all the mess on your paper. Get a whiteboard. Some of you don't like having all the mess in your normal paper. Get a scratch piece. Or, whoa. Aren't you doing homework in a homework spiral? Can someone show me a homework spiral? Let me see. What can you do? Ready? Cool. You know how you could open up to like a blank page and start your homework?
Yeah.
Where could your scratch work be? You could flip the page, you could have this be the start of your homework and have this be your scratch work and be like, ooh, it's nice and pretty. Ugh, it's messy. And you could show all of your, hey, let's double the second row and let's add it down. Go carefully, because what's going to happen with one little negative that didn't get distributed? What's going to happen with one little multiplication that didn't happen?
Already 6 lines.
Whoo! Whole thing's gone, right? Unless it's one of the step-by-step web-assigned ones that we hate, but it keeps us honest. So coming back. I went ahead and I doubled. Why did I double row 2? To eliminate the x terms and to carefully get what was left. Whoa, but that was only this. How did I get this one? I did a little bit of mental math because this one I just was able to, was that dangerous? Yes. Did it work? Well, I also did it in front of 20, 30 kids that were in front of me that were double checking me along the way. Right? Careful. So many places to make little mistakes. And if there are so many places to make little mistakes, what should our natural, it's not our natural inclination. We have to train ourselves to do this. But if it is a dangerous, sticky, tricky situation, what should we probably be doing? Slowing down, going more carefully, and checking our work. Do we like that? But do we like the nice right answer at the end?
Yeah.
So let's earn it, let's accomplish it, let's slow down a little bit. Cool? Okay.
Yeah.
After, and that was great. Great recap. After we got the x is gone from the first 2, the x is gone from the second 2, what do I do with those 2?
You
Eliminate
Do you see the system? Do you see the system? I'm not telling you this is the only way to do it, but I'm saying this is a systematic approach where one system could always work. Now some of you were like, wait, no, this couldn't always work. Because this system, you have to know to double it to make it, like a human has to do this. No, a human doesn't have to do this. Because guess what I could do? I could do something like, hey, let's make this, whatever this number is, call him A. Whatever this number is, call him B. Whatever this number is, call him C. And I could do something like multiply all of A by negative B, multiply B by A, and I'm always going to have it match, and I'm always going to have it cancel. I don't need to know the numbers. I don't need a human standing over this if I was telling a computer how to tackle it. We're trying to learn how to have a systematic approach. I'm not making you go all the way to the coding way. But I'm giving you that direction to say what's going to work every single time. Every single time. Get rid of x's, get rid of x's. Hey, cool, x's are gone, get rid of y's. Once again, I could have a computer call like the coefficients a and b and c. I could multiply them by each other. It'll always match ab. No, sorry, that'd be negative ab and positive ab. They'll always cancel. Or negative bc, positive bc. They'll always cancel. And the computer doesn't get scared with nasty numbers. We're human, so we're going to do the easiest way possible. We're going to see, hey, I can make it with a multiplication by 2, but we're tackling a systematic way of thinking. The y's are gone. Once the y's are gone, what's cool? I can just solve for z. And if it's not Sasha's case, if it's a number, what can I do once I have z?
Plug it back
Ooh,
in.
and isn't this a 3-dimensional coordinate pair?
This is.
It's not a pair anymore, is it? Set of coordinates, because a pair is only 2, x and y. So now it's a 3-dimensional coordinate, so x and y and z. Once I have z, I go back and I plug in. Plug in where? I plug
Back
into one of the
middle.
ones with 2. Could you technically choose? Yeah, you're a human. You can choose. Just go back and pick one of them. Solve for y. When I plug in 2, now I'm mental mathing, super dangerous, but 2 times 3 is 6. I think I can do 5 minus 6 is negative 1, but be careful. Some of that self-confidence is sometimes misplaced. For me too. For me too. Once we have z and once we have y, what can we do to both of these? Plug them in. And I can solve for x. Do we get the system? If you go about solving this your own unique way, am I going to be able to help you in class?
No.
Because couldn't we go about it so many different ways?
Yes, yes, yes.
But if we all follow the system, can't we find each other's mistakes faster? Yes, and together. Ooh, there was something to that prayer and I didn't even realize it. Okay, so coming back. Question, what situation, which picture goes along with the one that we just did? Which picture goes along with the one that we just did? Not perfectly, because I'm not saying that they're exactly the same, but it shows the idea. Right, you go.
First one,
Why?
because it's just 1 point.
Because all three-dimensional planes, remember, in 2 dimensions, it's a line, it's a line, it's a line. In 3 dimensions, it's a plane, it's a plane, it's a plane. They're all going to intersect all together only in one little baby point. And what's that one little baby point?
1, -1, 2.
Now, Sasha's case. Let's build up to that. The case that we love. What's the case that we love? The one that we just get to answer?
1 point.
Oh, I was thinking no solution. It's fast.
Oh, yeah, no solution.
Right?
Just
No solution would mean we would get down to this, and what would happen? 0 equals 0? Oh, no, there's no z. Wait, no, that's bad, that's true. 0 equals 5? Oh, no, there's no z, and it's false. Haha, no solution. Question, what scenario is no solution?
Inconsistent. That's how.
I'm not sure.
Our solution's not.
I'm not sure until I dig deeper. This one says absolutely no intersections anywhere. They're all parallel. This one says, well, there's just empty space. They don't all come together anywhere. Now, the nice thing is, I don't know if it's nice, but we don't dig too deep as to which one. We just say none, and we move on. Because we're looking for solutions. Neither of these have solutions. We either call them inconsistent, watch the directions, or no solution. That's 1 point. This is, didn't work, false statement. So Sasha's must be this. What does this say? Are there intersections?
Yes, sir.
But how many?
Multiple.
And not just multiple. 1 line, which means,
Infinite.
but is it infinite as in all, or infinite as in
Keeps on going.
certain, specific, but infinite? See what I mean? Is, for instance, in this picture, is this an intersection point?
No.
So it's not all. I can't just say all real numbers, because it's not true. That point is not an intersection point. Question, are there more points that are not solutions, or are there more points that are solutions?
No.
Whew, so you just told me there are different degrees of infinity. There are bigger infinities, and there are lower infinities. Interesting. I didn't trick you at all. It's very true. It's very true. There are bigger infinities and smaller infinities, or maybe a better way of saying this is faster infinities and slower infinities. And that's even the ones that are countable, then you have uncountable infinities. Anyway, no. Infinite, but not all. Infinite, but not all. Right? Okay, so if it's infinite, but not all, we have to have a way of talking about it. And what's our way of talking about it? Did you write it down yesterday?
But z equal a.
You get down to a true statement and you say, I don't know what z is, because z is not just one single number. So I say, okay, fine. Z can be anything. Why? Because we can make z like the vertical axis and we can say, cool, it goes forever. But will the x's and y's be forever also? No. They're going to be specific to z. So, those ones get harder. Okay. To that end, I don't know how far you got. Question, do you have this example in your notes?
Yes.
You got one with an A.
Yes.
Okay. Did you get down and did you realize why the A came about?
No, I didn't.
Do you know now, though? This true statement is saying it's not just one. That true statement says there are many. And as soon as that true statement, because I can't just get one answer, there is no z equals 2 and I can move on and it's one answer. I'm now all of a sudden in this linear idea that's like, okay, you could have let x equal a, you could have let y equal a, because all of them are infinite, and then figured out how the others are related to get them in the line. But we're all just choosing. We're choosing. We're choosing together so that we're all on the same page, like WebAssign would choose. We're choosing, let that bottom guy, the one that we would be looking for that didn't work out, let him be A. Because that's the easiest way to say, you're the infinite one, cool. How does y compare to your infinite answers? And then how does x compare? That's what we're doing when we say, what is z? I don't know. Oh, it's infinite. It's one of those lines. So let z, since these are all infinite, but not all as in I don't need a restriction. I do need a restriction. It's one specific line in space. Let z be, hey, z can be 0, 1, 2, 3, 4, 5, 6, and all the decimals in between and all the negatives on the other side. Let z be all those numbers. Now, how does y relate and how does x relate so that I'm on the one special three-dimensional line? That's what we're doing. Ryan, you then go.
Oh, on the website when I was looking, when I got confused ones, like I don't watch it, they were like using, like they were using, sometimes if they would pick and choose the number of rows, so like, they would take row 3 and use it as row 1 because its x coefficient was like, less than like the others.
Can I show you something real quick? What they're using is something that we saw in elimination. It's a legal step that just, I didn't show you everything. Oops. What's the very first legal row operation? You can change the order. So they weren't saying that's the only way to do it. I think they were like, hey, I would like it better, so let's do it this way. You can interchange the order if you want. Just realize that when you interchange the order, which I would sometimes do also, you've just added creativity to the system, and so you're kind of going down your own road. Does that make sense? It's not bad. It's not awful. It's just going to be hard for us to all double check it in class, but I could definitely double check it outside of class.
It's just harder because like the step by step, since you're doing it their way, you like have to like switch them sometimes.
Oh, because there was a walk there. Oh, okay, I got it. Yeah, it was a step by step. But if it was in the step by step, then we'd all be doing it. So the nice thing is, at least we're on the same page. But it's totally legal to interchange because what comes first, what comes second, what comes third. The ordering is not what's important. What's important is that they all stay together because they have a certain statement that they're saying, and that they're all being included, but the order does not matter. Ryan.
So I was going to say, does A represent all the solutions that could be possible that the point intersects?
A represents that there is an infinity that's representative in this line. The line does go on forever. But when we use A to get the others in terms of A, we're making sure that we're staying here in this infinite geometric piece of a line, and we're not like delving into other infinities that are not part of the solution.
So it's like the line that's going on forever that intersects.
Yeah, so if we think of, I don't know if Mr. Yu, did he show you like a three-dimensional system yesterday? I don't think so, right? If we were to take like our x and y, here's one way of representing it. Take our x and y, our girl fashion, two-dimensional on one piece of paper, x and y. Put it on a table, put it on the ground, and now have the third dimension coming up out of it. That's kind of the way that I'm representing the third dimension. Other people would make it x and y, keep it normal, and then have z coming out. There are different ways of showing the third dimension. But whether I have my plane, my x and y plane here with depth, or whether I have it here with height, it means the same thing. There's a third dimension. So Ryan, when I say let z equal a, what I'm representing is that I have this infinite, hey, I have all of z. But having an x, can I use this as an example? Is that okay? What was my y? My y was negative 1 plus 4a, which would have, hold on, I haven't done three-dimensional graphing in a bit. intercept of the z and y would be a -1 with a slope of 4. I don't want to go too deep because you guys don't need to fully understand this, but if I'm just looking at the z and y plane, for instance, for z equals 1, because z can be any number, then y would be, take that 1, multiply it by 4, so 1, 2, 3, 4, nope, that's negative, 1, 2, 3, 4. Take that 1, multiply it by 4, and then subtract 1. So my z would be 1, my y would be 3. I could come over here and I could plug in, and then I'd have 5 halves minus 1 half, which would be 4 halves. And my x would be 2. This is just for one point, but for one point, z is 1 when y is 3, when x is 2. That would put me somewhere in somewhere here. But it's hard for you to see on this paper because it's like, do you see that it's up in the air? Because it's totally up in the air. It's a little bit rough. Maybe it should even be a little bit higher, like up here. So I go up 1, I go over 2, and I go out 3. So it's hard to show like on a 2-dimensional grid because I would put it here. You guys wouldn't realize that it's up in the air, up 1, over 2, out 3. But then I would do that for z equals 1, and z equals 2, and z equals 3. Z equals 0, z equals -1, z equals -2. And I would get this one sliver in space. Because it's not straight up and down, but I get this one sliver in space that says, hey, z's are everything, but with that z, there's a specific x and a specific y that puts it on a specific line. That's ultimately what that's doing. Is it's getting us to that specific sliver, that specific line in space where all these planes are intersecting. Does that kind of make sense?
Yeah.
It's a little rough to show like on paper. There are plenty of really cool like computer, maybe I'll try to find one for next time that we can actually look at it. But the idea is, yeah, we're finding that one little sliver, that one little line in space where all of these are coming together. Oh, I had it in WebAssign so you guys could kind of see it, and we were going over there and using the stuff. But hold on, I just need to check what's in your notes. Did you guys get the non-square systems where you only had 2?
Yep.
Did you get the triangle? Oh. Okay. One of the kids that watched the videos were like, were we supposed to know what to do with the triangle? And I was like, I thought you got an example of it, but I wasn't sure. And then did we actually solve this one? Oh, but didn't I say it wasn't on homework anyway? Did anybody find one of these?
No, it's not on the
Okay, well, I'm going to go to WebAssign. Is that cool? Like, I just want to check what you have in notes. I'm
pretty sure Can you go back to the yeah there?
Yeah.
So how do you have y?
Okay, hold on, pause and respect. Andy has a question.
How do you have y equals 1/2 times 2 minus 8a? Like, where does that come from?
Can I make it big? And then can you point to me where on the screen I'm supposed to be looking, like middle, top, left, right?
Oh, I did this a different way and it made sense.
I don't. And why?
Oh, I was trying to show you the WebAssign way. Because the WebAssign way, as far as getting their solution, my way would have just been to take this and plug in let z equals a, solve for y, plug in let z equal a and whatever y is, and then solve. WebAssign's way actually scales it all back. What they're putting it in is what we call reduced row echelon form. And reduced form says I want 1s here.
What if they're different coefficients?
Well, whatever it is. If it's a 5, it'd be 1/5. I mean, I could tell a computer to do this too. If it's a 7, it could be 1/7. It's kind of showing me the system of what they'd have a computer do to scale it back. Because if I wanted a computer to solve the algebra, it would be a lot easier if I'm trying to solve for x and it's 1x instead of 2x. So if they multiply everything by 1 over the leading coefficient, and I have 1x, and I can just move everything else to the other side. Or if I multiply everything by the opposite, the reciprocal of this guy, -1/2, I have 1y, and I can subtract everything to the other side. So it's just an idea of how to get y by itself. It's not the only way. But it could be a way to tell a computer to get x or y by itself.
Yeah, but like, let's say the top one is 7 and then the bottom one is 2. Do we do 1/7 and 1/2?
Yeah, because this is going back to, just a second ago, someone asked about interchanging, I think Ryan Unin, right? And I said, hey, what's legal? It's legal to multiply by whatever you want as long as you multiply a whole line, a whole row, a whole equation by one number. So this just happened to be the same number.
Also,
They didn't have to be at all.
so for the y equals 1/2 times 2 minus AA, well, how do you have that? Wouldn't you divide the, like, negative 2y over to the other side, and then it would be negative 1? Like, in the second one?
So if we plug in a, and if we subtract 2 minus 8a, one way is dividing everything by a negative 2, but dividing by a negative 2. Can I write it?
Yeah.
Because you're seeing that you would divide by a negative 2 if you didn't do this mumbo jumbo, right? And if you divide it by negative 2, it's the same thing as multiplying by the reciprocal. Just remember fractions. So I'm doing the same thing. I'm just doing it in a different order.
Okay. And then you would get the same thing if you...
Because dividing by, which you would show with this, right?
Are you saying that way?
That
your
is the
way?
same thing as that.
Are you saying that way is your way? And then the
This
1/2
is the systematic way of getting them all reduced and then solving for x, for y, for z.
So you can just like.
And by reduced, I mean with a leading coefficient of 1. Sorry, Natalie, go ahead.
So you can just set z, because this is what I did, and you can just set z equal to a and then solve for y.
Mhm. But some of you are going to see their version of writing it and your version of writing it, and it might be different. They shouldn't mark it wrong, but every now and then they might, if it's like one of those fill-in-the-blank ones. So I was just trying to show you, or Ryan, for the fill-in-the-blank one, if they're like getting you to scale everything back and having you do this step of getting that leading coefficient of 1, I didn't want you to be lost as to what they were doing. They were heading further, deeper into the system of computers don't care if the numbers get messy, just make the leading coefficient of 1, and then you know how to solve the algebra. It's easier to code that way. Jackson.
You're just like trying to cancel the y's, right?
You're trying to solve for the y's. This step that Andy was asking about was trying to get this to be a 1 and this to be a 1 to be able just to subtract to solve.
So even though there's not like a, so there's not like an x in the second one. So how did it?
Right, just like there wasn't an x in this one, in the second one. Because the system, and this is the row echelon form, it's a special name, and this is what they're trying to do. They were able to steal this one because it already had a 1. They didn't have to do any extra work, so they liked that. They were able to steal this one. I think actually WebAssign usually steals the second one for some reason. I know your calculator, I think, when you learn how your calculator can do this, I think they steal the second one. I stole this one. It already had a 1, so there was no extra work to do. And then your z equals 2 already has any work, but or already has the alone. But Jackson is the same thing of just we go up one step to plug in and solve for y, right? And then y equals, after a little bit of work, negative 1. And then we take our z and our y, right? And then we solve for x equals 1 after some work. But their idea is, like what Andy was asking, is they like having these be 1s, and if they're not naturally 1s, they make it 1, because then a computer, if you just like say, whatever, get rid of this leading coefficient, then we can always just say, cool, and let's do the opposite sign, one quick subtraction, it's just a little bit easier to code. This is what they're doing, is they're getting that to be a 1. If it ever forces your hand, like Ryan says, sometimes you have to fill in the box. So I was just preparing you for what the system is, and it helps us out with matrices, something that's come in just for you to be like, oh, hey, this is legal. I wouldn't do it myself, but okay, cool. They want to, let them do what they want to do. Andy.
Last question, and then why didn't you, like in the new one, why didn't you change the, like, in the regular equation in the top right?
Okay.
Why didn't you change the z's to a's? Like,
Oh, because I was showing you just like I did over here. I hadn't plugged anything in yet. I was just showing you like, hey, this is what we call a reduced version of the original system that is easy to solve. Like we started off class when I asked, hey, what would you rather, this or this? The question is, or actually the answer is, they're both the same. These are the exact same system. Just one is like my original, and the other one is what we would call the row echelon, actually the reduced row echelon form. They're equivalent. I was just showing you with all the work that we had done, we had made it the nice version that's really easy to solve. Does that make sense? So I hadn't actually started solving it. I was just like, look guys, we did it! Awesome, it's easy, let's go. Is that cool? Yeah. So I'm showing you that like reduced form of the original system that's so easy to solve. Before we totally go away from the notes, I know you guys did it without me, but real quick, if you only have two equations, what do you have to just start by doing? Yeah, that makes the third, and that third we can just let z equal a, right? So this is saying, hey, you can't get to a pinpoint. Why? Because I only have two planes, and two planes will always intersect in a line, so just go straight to the a thing and solve. And then did you get the whole, like, stuff has to be 180, let's make little equations and we can solve? Cool, then I'm good with us going to WebAssign and checking out questions that you have. I'm cool with us going to WebAssign. I'm going to go to the very end of notes, which is right after the homework page. And as, yeah, go ahead, start shouting out. 14?
Yeah, the triangle one. I think it's the last question. I did something wrong in my math and I don't
It's so easy, right? Anybody else have one that you've gone wrong in the math? I would love to help. Yeah, take your time. Take your time. Let me know when you have a number. Somebody in the back, Joey, did you have one?
What?
12. The first one was.
There was one.
Okay.
Yeah.
Was it one of the fill in the blank ones?
Oh, I got
Yeah,
the
because
bonus
it was
one.
like blank.
Okay, let me give you guys time. Get into WebAssign if you want to get into WebAssign. Get into your homework spirals. I'm going to go get some people that are joining us from other class periods. We're about to go through and do some homework questions that were asked that included, someone needed 10, but then they didn't need 10. Oh, where'd my X go? Come on. So we're going to do 9 last. That was the last question that came in. We're going to do 11 and 12 and 14. Maybe not the whole thing, but at least trying to find people's mistakes if they made them. And then if you are bored, the Jamboard for 7.4 is up, and you can go do that now, even though hopefully you guys are watching the video, but some of you choose not to. Awkward. Okay, here we go. 7.3. Ba-doop, and ba-doop, and ba-doop, boop. Who needs number 11? All right. All right. So, let's try to check. I'm guessing a mistake, Ryan, because this is what we would call an... Ooh, what would we call it? It's missing that third equation. We're going to automatically do it because I didn't teach it the other day. It's not nonlinear. Non-something. Does anybody have the word for it? No, not non-congruent. Non-square. There we go. Because I have a 3x2 instead of like a 3x3. That makes sense. And some of you are thinking, like, I'm just looking at the number of variables and the number of equations. So, non-square. Missed the word. Okay, so, we automatically know it's a z equals a because there isn't a third equation, so it's impossible for me to get that. The tricky part of this one, bud. Hey guys, respect though. Respect. When I take questions in class, we show respect and let people hear the solutions, okay? Quiet on down. I can only plug it in one place, right, bud?
Yes.
So then when I throw it into that one, I would go ahead and have my original equation, or I should say the equation that stays the same. So I'm going to have to use that. And then I have this other guy, which is going to be 2x minus 3y. I'm going to go ahead and subtract on both sides the minus a. When I do that, plugging in.
Why did you say A again?
Oh, because I'm plugging in. Plug it in, plug it in.
Does it like tell you to do that? Or?
It as in the problem, no, but it as in all the examples in the notes, yes. So remember that we mentioned if you get a true statement when solving down, we let z equal a, and then we're doing back substitution to solve for everything else. And then also in the other example, hey guys, in the other example, when we have what's called a non-square system, we have that third, like to make it nice and proper as far as with 3 variables, we need 3 equations. That 0 equals 0 is our bottom equation. we let z equal a, we have to back substitute like we do with every single one to figure out how x and y relate. Okay, so we're always back substituting. Either a number, or a no solution, we're done, we're not doing anything, or an a. We're always back substituting. But the problem is I can't go back here because there's no z. So I'm going back to the only place there is. And the only place there is that guy. But I'm going to have x's and y's in both, so I'm just trying to get it to where I can actually do elimination. So it's a little bit non-traditional because there's not like an a everywhere.
Yeah, I'm just confused because in the true statement, then 0 equals 0, then you plug in the a, but I just...
Oh, okay, got it. Sorry, I was going straight for the solving because I was assuming you already started. So yeah, we would go ahead and add that 0 equals 0. We would have already done 2r1 plus r2 to eliminate, like we would do with any system in this section. And so then that would get us with a 4x minus 6y plus 2z. I was trying to shortcut it, and that might not have been the wisest thing. So I'm trying to eliminate, so I have 4x minus 6y plus 2z equals negative 10. So yeah, right, I can do the system. And then I'm keeping this the same so I can eliminate. As I do that, I get rid of the x's like the system would say, right? I have 3y plus 2z equals 13. So then I would keep going to eliminate my y's, but I don't have a third equation. So as I think you already said, 0 equals 0, let z equal a. The system I would be solving, like just me choosing as a human, I would be solving this. If WebAssign was doing it, if a computer program was doing it, they would do another step. Well, let me finish the system, z equals a. They would not be happy with this. They would be multiplying everything by a half, and they'd be multiplying everything by a third. That's what like a computer would do, or a programmer would have had happen as the next step. We don't have to because we are humans. So if this feels a little better, then I could go back traditionally and just plug in. I was going to kind of just make it work. But you're right, that's not very systematic. So as we plug in, we get 3y plus 2a is equal to 13. With a little bit of, getting y by itself, which you guys have been doing for a long time in a lot of different contexts. I would subtract and then divide, and I would end up with y equals subtracting 2a and dividing by the coefficient of y. Would get me this guy. And once I have that y term, I could go ahead and plug in that z and plug in that y, right? And I can work my way back to solve for x. So 2x minus, well the nice thing is 3 times this thing over 3, the 3's go away. Is that good, Ryan? Can I get those 3's reduced?
Yeah, I'm just confused on when you said z equals a. How did you get the statement where 0 equals 0?
Yeah, once again, it's from, maybe you don't have that example in your notes. And I wasn't here physically teaching you, so I can't regurgitate the exact words I said last year or 2 years ago. But what I can show you is the work you should have in your notes currently. Anytime we have a non-square system, we only have 2 planes. And 2 planes cannot possibly intersect. If they intersect at all, they can't possibly intersect in one point. Instead, they would be intersecting in a line. And so that's that whole z equals a situation as far as I don't have a third equation. And so, like I modeled, and once again, I can't regurgitate the exact words from the video. You can go back and watch it again. I should attach those links in the assignment itself. But we form a third equation to make it square. But the only equation I can form that I know is true is 0 equals 0.
Yeah, so every time you only have 2 equations, it's just implementing solutions.
It's just, say it one more time.
Every time they only give you 2 equations, it's just infinitely many solutions.
Right. It's just going to be infinitely many, and how we go about solving that. So a step to the system, like it was here in the example, but maybe I should have said it here, is that we always let z equals a. Which is what I put in the picture back here, but I didn't, you know, and I apologize, I didn't tie the idea together as far as also saying whether you end in a true statement or whether you have a non-square. My hands are tied with this guy because that's the only option I have. So now does it make sense why I'm doing that z equal a?
Yeah, then you just eliminate the two equations, and the one you get, you just substitute in.
Right.
Okay. Thank you.
Then I would just do, can I just do it dot dot dot? Is that cool?
Yeah, cool.
Anybody need number 12? Joey and others
Yes.
for WebAssign. Number 12. Chris and others with WebAssign. Filling in number 12 can be a little bit rough, okay? So I'm at the very beginning. I have the first two steps ready. And then those of you that, I can make it a little bit bigger. Is that good? Okay, this is, okay. You know how you guys told me, like, oh, you don't have a homework problem, like, you didn't have a homework problem that's talked about motion and velocity and acceleration, but you did have one that needed the math. And so check it. How many points does it take to make a line? 2. For a circle, you just need 1 point and like a radius, a center and a radius. For a parabola, I need 3. We can't just do 2 points for a parabola, because if we had 2 points, well, I could say, well, what connects those 2 points? Well, I don't know. Well, maybe something downwards connects those 2 points. Haha, that's a parabola. Maybe something upwards connects those 2 points. Haha, that's a parabola. Maybe I need more than 2. 2 points determine a line. 2 points do not determine a parabola. I need 3 points. And another way of seeing why I need 3 points is because every parabola, to begin with, has 3 unknowns. What happens if you plug into the general parabolic equation x's and y's? You have x1, y1, x2, y2, x3, y3. They're saying plug, I literally plug in. You're like, okay, fine, plug in. Plug in where? Plug in up there. Okay, cool. If I plug in, I would say y is equal to 6 when x is equal to, well guys, what's a times 0 squared? Plus b times 0 plus, the first equation is c equals 6. The first equation is c equals 6. Then I would repeat a very similar process as far as plugging in 7 with 1. Like, I'm just saying, hey, this needs to be true. Similar to what you would do if you had 2 points trying to make a line. You could plug in xy, plug in another xy, solve the system. I'm plugging in 3 points that I know are on the parabola. Which is technically how, like, a computer graphing system could take snapshots of something that's flying through the air, or someone that's flying through the air, and they could take a few of those snapshots and then form a parabola. It's basically doing this procedure. It's saying, hey, here's a position, here's a position, here's a position, throwing it in, they can extrapolate and get a regression. I could plug in 6. But I'm just plugging in. Does that make sense, guys? So therefore I could take a peek behind the curtain and say, so what's going on back here? It should just be, that's not what I wanted to move. Where's the other side to the equation? Hold on, let me go to WebAssign for a second. All I see is the C and not the C equals 6, so that's a little weird. What was it, number 12? Oh, they have the equal 6. I took that off, sorry. They have the equal 6, they have the equal 7, they have the equal 6. So that was my bad. I accidentally made my box too big. Can I make it smaller? There it is. My things are too big. Okay. So they just rearranged it to where the y's were on the other side. They said, hey, so then think about this as being equals y. And so then they had over here the equal 6, the equal 7, the equal 6. And all you were trying to plug in was this part. Let's simplify. Which for this guy just ended up being C guy ends up being A plus B plus C. And then for this guy, it ends up being what? 4A plus 2B plus C? And I know it's not X, I know it's not Y, I know it's not Z, but kiddos, don't you have a system of equations that you can solve? And if you were to set this up, I mean, you could even say like, hey, cool, look, I have C equals 6. I'm all ready for that Z equals at the bottom, and then all I would do if I were you is maybe like make this row 1 and make this row 2. I'm just writing the pretty system. Like, your job is to solve it, for sure. But then, yeah, Ryan, what were you saying? We could do elimination, right?
Yeah, we could like cancel out the A's.
Yeah, I would do -4, row 1, plus row 2. And I would just go very, very carefully, but -4A, -4B, -4C equals -28. Don't forget to go all the way. It's so easy to forget that number. And then 4A plus 2B plus C equals 6. Kiddos, you don't need me. Solve that, get your second equation, and back substitute. And then you'll find your A, find your B, find your C, and I believe that's what they're asking for next. Is that okay? Is that okay? I'm just eliminating the A's the same way I would eliminate the X's. And I believe in notes, only if you're a color coding kind of person. I believe that was blue. Eliminating the A's. Plug that in. And when you're ready, you're going back and back substituting, and you already have your answer right down here as far as C equals 6, and you're just trying to find your B, trying to find your A. Let me know if you get stuck on that. However, I did promise that I was going to peek at number 14. Ah, this is the one I like. I just think it's fun. Because it's geo, though. Like, you can go do so much more than you could when you first took geometry. For instance, this isn't like football where you're like, where did that equation come from? It's like, no. What adds up to be 180, cool kids? That's the easy one. But what else adds up to be 180?
1.5.
What about linear pairs, right? Yeah, but I'm going to write it in a pretty order. Is that okay? Because it's going to be 1x plus, no y's, 1.5z equals, can't I do like 180 minus b? Can I do something like that? Because the b, like it's going to be this plus this plus this is 180, move the b this. And then I could do y plus 1.5z is equal to 180 minus, no, plus c. Does anybody see that everything has a z?
Yeah.
Oh, and they also gave us what C and B were? Oh my goodness, that just got so much easier than I thought it was going to be.
Dude, that's what I was saying.
Yeah. Yes, ma'am, yes, ma'am, yes. You're supposed to read the problem first? Oh my goodness, no wonder I used to make kids write the directions and the problem down to make sure they knew what they were reading. Okay. So what is it? Minus 7?
Yeah. So 193.
And then plus 15.
195.
Haha. Do. I could eliminate the x's pretty easily with the first two, right? So row 1 minus row 2. Then that guy already doesn't have any x's, so that's going to help me out a lot. Because then I could have x minus x goes away, y minus 0 is y, 1 minus 1.5 will be minus 0.5, equals 180 minus 180 minus a negative, is that 7?
Where'd the B go? Like when it's a plus 1.5?
Oh, sorry. This ends up being a 7, so I moved the 7 to the other side, and that ends up being
That's what I
173.
did.
And C is 15, so I add the 15 to the other side to make 195. Is that cool?
I added the 1.5, the C, and the Z instead of subtracting.
Oh, killer. You gotta distribute. Poor little seal. Save him.
can stop if anybody else has it.
Okay.
Anybody else
Are the rest of you guys good on this?
Yeah.
Yeah.
Because then we would end up with, and then I would say eliminate the y's, beep, 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 solve for the z, and then back substitute, boop, 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 all the way up. And then there was a question on number 9, yeah? I don't know who was looking for 9. Who was looking for 9? P.S. For those of you guys that have not paid attention to a question all day because you weren't there in homework yet, A, it's in the video. And B, we are now to a traditional, the rest of homework question, right? Wasn't like everything before this either vocab or these guys? 10 got weird. Was that it, Ryan, with the 2? Or that was 11. 11 got weird with just having 2. 12 and 13 and 14 were getting all application-y. This is like a, let's go. So Ryan, how did you go first? Did you eliminate the x's on the first 2? Cool. And when you eliminated the x's on the first 2, did you get them both to be 10? And which one did you make negative, the top or the bottom? Just so we can be on the same page. Bottom was the negative one? So I believe he did 2r1 minus 5r2. Does that sound right? Okay. So that would be 10x minus 6y plus 4z equals 46. And then that'd be negative 10x minus 20y plus 5z equals negative 115. Double check my numbers, bud. Is that looking good?
Yeah. Oh, I think I already seen it.
Double check though. I'm not even slightly pretending to be infallible in this, especially when I'm on a whiteboard and I'm talking. You guys can hear that more Promethean boards are coming. English rooms, history rooms. I'm not sure everybody, but somehow they got a grant and they're gonna get more. 31. Negative 69.
Yes.
And then we would need to also eliminate the x's on the other set of 2. Do you want me to keep going, Ryan, or are you good?
I think.
Okay. Anybody else want me to keep going? I can keep going. Keep going? I'm going to go ahead and eliminate on the next set of 2. Is it okay if I just multiply everything by a negative 2? Right? To make it go away? Okay, so I'm going to do row 2 minus 2 row 3. Okay. So that's going to be 2x plus 4y minus z. And then multiply everything by a negative 2. So negative 2x plus 22y minus 8z. Guys, once again, there is no shame in slowing down. Slow down. Take it turn by turn, step by step. Just practice your multiplication, addition. You do not have to be like busting through these. I always go back, just especially if it's long. Times a negative 2 times, I'd rather catch it now, times a negative 2 times a negative 2, multiplying every step, times a negative 2. Awesome. Let's go. I don't remember what color was next. I'm just going green just because. I'm going to eliminate the y's. If everybody agrees with what I got. As one version. If you put a negative somewhere else, you might have the signs be a little bit flipped, but it should still end in the same spot. Oh, it's gorgeous.
Yeah.
Look, I can just add down though. I don't mind this. Check it. I probably wouldn't have even paid much attention. I would have just gone for it, but I'm trying to be nice and neat and clear. P.S. All this is adding because I'm making them the opposite. What happens, cool kids?
No solution.
Woo! It's gorgeous.
Yay.
All right, let's go play with section 7.4. We're just starting it. But I'm going to set a timer. So that you guys can finish up, solidify, submit. I don't know. Whatever it is you're working on. As we're getting ready to go to section 7.4. If you want to stand, if you want to stretch. Oh, 7.4 is so helpful.
Oh, really?
Ah, you don't need that much time. Let's go 3. I'm gonna stop talking. You guys finish up whatever it is you're working on. Stretch it out. Walk around the room. Stick your head out.
Yeah.
Hallway, whatever you need. But as we come back, 7.4. Don't go out of the hallway, but you can stick your head into the hallway. Don't disturb, don't mess up. Yeah, Jackson, what can I do? Yours is a strategy? You know what I mean? Like, it's a strategy. I just, it's not how I usually No, go play.
Do you know anybody who wants to?
I did the extra thing too. Let's look at bring it.
Do you read or have a 6 test?
You would, but one kid still needs to take it.
Oh my.
Get on it. You know who it is.
Oh yeah, this is oh my god.
She started it, she just needs to finish it.
Look at her.
She started it, she just needs to finish
No playtime. No playtime.
it. Because then when you guys get back, you can do corrections. Alright guys, that was the bell. Let's make our ways back to the seats. That was a bell. Let's make our way back to the seats. Whoops. See, I became great with
No way.
Words, Ryan. Oh, there's something wrong with my charger. Oh, do I don't do it?
Alright, here we go. I think everybody's back. Question. Before we start 7.4, don't worry, this does not need to go in your notes. Question. First of all, you guys are seeing that most of your tests are graded, and then you would get them back today, but we have one person who still needs to finish it. So, you get it back next time. You get it back next time. So, listen. You will have a chance for corrections, but please realize if you're like, oh, I wish that grade was on the end of the grading period. You guys didn't have a chance for corrections.
Yep.
Which is one reason I didn't hand it back. And for some, it would have very much helped or kept your grade where it was, but for others, it would have tanked it. So I was trying not to, like, I just had to consider everybody, and I did say if you didn't have a chance for corrections, you could, I don't tend to, like, throw that in right at the end of the grading period. Some of you might be wondering, chapter 5, wait, we never did corrections. Well, there were formulas that were just memorizing, so I wasn't going to do corrections on those. There was a WebAssign portion that you could use each other in notes on. I wasn't going to do corrections on those. And the one part I would have, and I did offer another opportunity, was the T-proof portion. I said that entire week that you could come in and take another T-proof, and I could replace it if you wanted. No one took me up on that, so it was what it was. But chapter 6 was a traditional test. There will be traditional test corrections. Once again, some of you did end up doing quite well. However, quite a few had the grade that you thought you might have had, where the corrections will be beneficial. That's why I didn't go ahead. Okay, my question to you is, how useful in math is the ability to, can anybody fill in the blank? Okay, there's a lot of things I could fill in, right? Right? What is the word that's going to be helpful for partial fractions? The word starts with a U and ends with an undo.
Undo.
Inverse fraction.
Okay. Question. Where did this whole journey of you guys using, solving, making variables start? Where did it all start? Oh, before that. Where was it?
Learning the alphabet.
Maybe pre-algebra. You might have been the first place you saw variables. I was thinking more algebra 1, right? The idea of I don't know can be a letter. And with that comes the power of, hey, but wait a minute. I can take what I do know, and I can find what I don't. It's kind of the basic idea of just using variables in math. Besides the fact of being able to generalize and blah, blah, blah. Okay. In Algebra 1, where was undoing necessary, helpful, important? Think of like the most basic algebra thing ever. Or just give me an example. Where was undoing helpful?
I was just saying absolute value just randomly.
Oh, you did see absolute value randomly. Talks about the power, the magnitude. Now you just saw it with vectors, the how muchness, the speed. But Ryan.
Maybe like if something's like squared, so you put it to the
Oh, you're getting like to the very end of Algebra 1, maybe even Algebra 2. But yeah, if you have something squared and you're trying to go backwards, right? But even more basic than that, getting x alone. What if you have x plus 5 equals 7? Some brains are like 2, duh. Some brains are like, I don't know. So you subtract 5, right? Or if you had something like 3 times x minus 1 all over 7 equals, you got to do some undoing. Right? You gotta do some undoing there. Okay, so undoing was helpful even then, but now that you've been in, now that you're in pre-cal, haven't you also seen things like, hey, when is, right? We gotta do some undoing there. We have to think backwards. We have to think of going back. Or maybe something like, what kind of undoing do we need there?
quadratic.
Foiling is actually getting it to be this. What's the undoing of foiling?
Box
Factoring. Yeah. Which one did you learn first though?
The box.
Foil.
The box method or the foiling is what you learned first, how to multiply, and then you learned how to undo?
Yes, sir.
What on earth does this have to do? With this guy? What does that have to do with this guy? This guy says, what if I was to give you something, for instance, like 2 over x squared minus 5x plus 6. What is the undoing of this? And that's what this entire section seeks to answer. It's an undoing that you haven't seen before. It's an undoing that says, hey, that could have come from a this and a this. What? Wait. What do you mean that could have come from? In math, in so many different situations, it can be helpful to break down. It can also be helpful to build up. It can be helpful, do you remember the math words for those with exponentials and logs? The helpful to what? Expand and condense. This is a condensed rational function. This is an expanded sum of its partials. This is a reduced down, aka common denominator. What? Is that a verb? Not really, but I just made it up. Because couldn't you multiply by this over this? And couldn't you multiply by this over this?
Yes, yes.
Yeah, I mean, that was just like an application of common denominators this year. But common denominators, haven't you ever taken something and put it together? It's just been a while. And you've been doing it with trig most recently, but we're not doing trig right now, we're doing algebra. Guys, what is x minus 3 times x minus 2?
X squared minus 5x.
And if I had common denominators, couldn't I mush it all together?
Yes.
But the question is, what would have been in this spot and what would have been in that spot? Well, cool kids, what do we do since Algebra 1 if we don't know something?
No solution.
That's what you do in WebAssign. Impossible, maybe it's right. But coming back,
That's the first thing I tried.
7.
that was a roast. That was a roast. But I understand that is what some of you try. But coming back, that's not the right way to do it. Sneaky, but not the right way to do it. What's the right way to do it? We make a variable and we say, okay, let's go find it. What? If we don't know it, we say it's unknown and we call it a variable. Ooh, I haven't taught you anything yet, or have I? Maybe I didn't need to teach you how to do this. I just told you to make a variable for what you don't know. Anybody have an idea of how to get A and how to get B? Substitute? I don't know. I think we could just go playing with numbers, but that's dangerous. Can we solve? If we have an equation, come on, play with stuff. What can we do?
Multiply.
Multiply both sides? Sure. By what? Let's undo the division. Let's undo the division. What happens if I multiply? I need to get rid of division, right? But isn't that the same thing as this? Right?
Yes, yes.
That'll get rid of that. And what do I have left on that side?
2.
But what is so dangerous?
You need
I did
to-
something
you need to
horribly
multiply.
illegal in algebra. What I do to one side, I do to the...
Other
Okay.
side.
There's not a lot of room. Can I do it this way? Can I put one here? Because I have to distribute anyway, right? And can I put one here? I have to
Yeah.
distribute. What's so cool about what I have?
You cancel out all the denominators. So
Nice.
A plus.
And nice. So what's left?
X minus, or X minus 3 plus. It'll be X minus 2.
Now, from what we just learned, how can we have 3 variables and need to find answers with one equation? That's impossible.
That was 0. Oh, you have to make the other
Unless...
Wow.
That's too complicated.
That was big brain.
What? Oh, I see.
I'm pretty dumb.
I see what you did.
What I do?
You like took like 2 groupings or whatever. And yeah.
I mean, the first step was easy. I just distributed.
Yeah.
Yeah, that makes
And I
sense.
brought my X terms and said, hey, you're kind of like. And the non-X terms, you're kind of like.
Why did you put a 0 right next to the other side?
And then I said, well, wait a minute. You guys somehow had to make the X terms, didn't you?
Yeah.
But I don't have any X terms. Oh, that means something.
Make up one.
And you guys have to make the numbers because you don't have any X's, and well, the only number I have is this. So why is this section coming after all that we just did? Well, because, cool kids, it's going to be solved by,
Quadratic factors.
oh, not even that hard. Don't I just have a plus b needs to make a 0 because all the x terms went away and I didn't have any x terms left?
On the way.
And then doesn't negative 3a minus 2b need to make, wait, what did all the non-x numbers have to join to make? I got myself a system of equations.
Oh my
At
god.
least
Now.
it's not 3.
What is this?
What
This
did
is
you
called
start
partial
with?
fractions.
What did you start with? Like in the beginning, the
And
very
just
beginning.
eliminate.
I started with somebody that I was trying to break down into its partials. I was trying to
So they
expand.
gave you those 3 things.
Well, technically, they're not going to get you that.
Oh, so then.
They're just showing you, do you
okay,
know
okay.
that can actually come from that? And it's like, no way, really? And it's like, yeah, really. What? How could I check? Well, I would multiply and say, no. Does it really make what's over there? So I would
So-
check it, and I
they
would
give you-
check it. This is just discovery. Like, guess what? They're the same.
So they give you what's on the left, and then you make what's on the right, and then you
I'm trying to take something and break
multiply
it
by
down.
the denominator.
That's very good.
So this is going to end up being the exact same thing. The question is then,
So then you try to find A, B.
well, after talking through some steps, break it down, break it down, break it. Do you see it? We're breaking it. And then we're breaking it down.
Oh my god.
No, don't.
What's our job today?
Get the foundation.
Start. Start. What did we start with? This word's important in math. Expanding and condensing has been a thing we've seen before, where sometimes it's helpful to have it all brought in, but sometimes that's messy and tangled, and I would much rather have it be simplified in its little baby pieces. So then we have this whole process that you guys were trying to write through. Now you wrote some of the steps down. Some of you are looking to see if there are more words that you want to add, but you've already started. We'll add to this next time. But here's the idea. In a simplified, oh my goodness, wait a minute. What were the words of the first step? Okay, so my simplification of what was there. Oh my goodness, we still have 2 minutes left, my little middle schoolers. Act like high schoolers. Come back. Divide when improper. When the degree of the top is. And now you're wasting more time. Shush. When the degree of the top is greater than or equal to the degree of the bottom, aka I have a top-heavy rational function. And what I mean is by degree. I don't mean by numbers. I mean by degree, by powers, like a quadratic over a linear, like a 4th degree over a 3rd degree. I have a stronger numerator than denominator. I need to divide first because it is not ready to be expanded yet. The first step to breaking it down is dividing by putting the numerator in the box, the denominator on the outside. If it's ever top heavy, you've got to break it down with division first. When I finish, I will get some sort of quotient
Oh, that's a D.
plus some sort of remainder. Remainder. And that remainder, I can take that remainder and I can actually say, hey, you're like a fractional piece. You're a fractional piece of my denominator. And then it's like, okay, after doing that, I'll break you down. And then we go down to the rest of the steps. But that's only very, 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 very special. For instance, that is not necessary in this problem. Why? Because he's a stronger degree on the bottom. It's not top heavy. He's a stronger degree. Not necessary. Same thing, stronger degree. Whoop. Necessary.
Oh,
It's just a division.
So you only use
It's just a division.
what is that?
It's just, okay, it's not today. It's not today. Take a breath. It's not today. Okay, come back.
First example.
Then, what are we going to do? You're going to do exactly what you just saw me do. You're going to factor that denominator and say, well, what are the partials that it could come from? We're going to figure out how to write those partials. Then we're going to use systems of equations to solve. But did you guys see? I get to hold you after the bell for 50 seconds.
I see that thumb trick.
When the bell rings, stay in your seats because you just stole time from me. I won't start the 15 seconds that you stole until you're all seated and quiet.
Sasha, shut up.
So did I have the whole process? Yes. Are we going to learn it? Yes. However, do you see something cool that this says?
I'm counting my fingers.
Maybe There will be some shortcuts along the way. Now you can leave. Bye. See you later.
Sorry, no, 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 you have a lot more room.
Killing me, Smalls.